thing I forgot to mention was, how do you test for something being a conductor, to see if something is a conductor? Well, it's very simple. You get a battery like this, you get a light, and you know, if it's a conductor, it's going to, there's the light, and let me see, there's lacquer on this surface. Is there, yeah, there's lacquer on that surface too. So, there we go, there's no lacquer there. So that tells you electricity is going through it, it tells you it's a conductor. Okay? This is called a continuity checker, and there's also a continuity checker in the fluke. Yes, you put it on ohms, and it'll check continuity as well. It usually gives you a little, boy, I don't know if you can hear, the battery is very low. And that's how you check continuity. That's one way of checking cable, for instance, to see, you know, if it's working or whatever. So that's the way, that's the continuity checker. This is the way you determine if you have a substance and you want to find out whether it will conduct electricity or not. Just do it like this. This is a very handy testing device. Okay, we have some resistors here, and we're just going to show you this little gimmick. This is a variable resistor. They call it a potentiometer. And as you turn it, you can increase and decrease the resistance, and there you go. You can see how that works. Okay. So we have a whole bunch of resistors here, and the little project is to take a resistor and find out what the resistance is by reading the code, and then come up and use the meter to check and see what that resistance, if that is correct. Now, what you're also going to do is get the tolerance and figure out what range the resistor is in. Okay, so if it's a 10% tolerance and it's 100 ohms, then you're going one way and the other. It's 90 to 110 if it's a 10% tolerance on 100 ohms. So that you need to know how to do. So just come up and take a resistor, or I can hand them out, we can pass them around. And don't, with these, it says 560 ohms, but don't trust it. Test it on the machine. Yeah, that's an easy one to read. So
I'll take that one there.
everyone can hear. So try and read the code for yourself. And we'll put it up here. Sorry.
There's numbers stamped in that case.
Oh, you want me to read
if you
this
look
too?
closely,
Oh, yeah,
There should be numbers.
I was going to say, I got one already.
The potentiometer.
Yeah, I know. Yeah, I know. That's range.
Yeah.
Okay, ABC band.
What's inside is the biggest thing.
So once you arrive at a
Yeah.
resistance, come up and test it.
Cheers. Hey, I can see the colors.
So George, let's figure out what range that potentiometer has.
Yeah,
If you
they don't have their range. They got a model number on it, that's all.
bring it up here and we'll test it, okay?
Yeah, oh yeah, then you can test it. Yeah.
We'll test it. Okay, so to test the complete resistance, this is the center tap, right? So to test the complete resistance, we'll do this. And it's 4.8. Yeah, turn it. So it's 4.8. Turn it all the way one way. It's 4.8 kilo ohm. 4.8, it's all 5 kilo ohm. And all the other way. Yeah. 4.88, oh yeah, 4.88 is the entire, yeah, and it goes from 4.88 to the lowest, resistance,
To 1.9.
1.9 ohms
Yeah.
to 1.9 kiloohms to 4.8. So that's the resistance of that. What did you
You're
have?
measuring both ends on the other one. 6 kilos.
So that would be a 5K?
56.
That's probably just 5K. Yeah, it's always a little bit of loss or a little bit of a gain for.
10K, 2 to 8.
Yeah, it's really okay.
6K.
I'm not getting a good
4.8,
contact.
it's gotta be a 5.
Oh, no, I'm sorry, 4.8, yeah, I know it's 5.
51.3.
The tolerance is 5% on 56,000, so that's...
Is that in the ballpark? No, this is not the accurate resistance, eh? It's probably making that.
Green and blue, so that's...
Oh, if you're touching with both fingers, you'll affect
5,
it.
6.
Sometimes you have to take one finger off to make sure you're not being part of the circle. You're touching with both fingers and sometimes.
Ah, there you go, you're right. You're right.
The human body.
57, that's as good as close enough.
Yeah.
Okay.
Okay. And there's one year I was kind of, I was just wanting to see if 120 was hard. I was touching it, I really wasn't even getting the shot.
Yeah, okay.
Dehydrated.
Okay, anybody else want to test their resistor?
Okay, so I went down there, that's the last one again. 10,000, so 154K.
Resistance, yeah.
Yeah, 'cause then the
Okay,
last,
so what do you think it
numbers
is?
when you go down, 'cause gold doesn't have anything.
521K?
Well, we'll see what the black, this is 0, or 1 base. So then it's pulled through from the brown.
Okay, so then you're,
Resistance.
Whoa, it says 0.88.
5.
Okay.
154, and then,
Yeah, the gold's over there, yeah?
and then how do you
So
figure out
gray is,
what that is,
gray is 8. Yeah, so it's always given.
okay.
Oh, gray, oh,
Yeah,
yeah, so it's 0.8 kilo,
Amazing,
0.8 kilo,
amazing.
or 889 ohms.
Okay, so that agrees,
The gray is 8, yeah.
and this red is,
The red is 2.
and then that's a 1.
What is that color? Okay, and so it's a 1, yeah?
So that's 821, that's not,
Yeah, it's off.
it's plus or minus 10%.
Yeah, the gold is 5%.
That should be.
So it's, yeah, it's not as good as we think it is. No. These are old resistors, so 56K?
At least 10.
I can get you finger up.
Yeah, it won't hurt it here.
That's 57.
Plus or minus
57.
5%. So
No, it's within.
Good
so I
one.
got 154, I don't know what it was. Okay.
154K, absolutely correct. Anyone else want to test?
The resistors off.
So,
When they wrote out,
Oh, yeah.
You are jumping around. You are 749K. Whoa!
Plus or minus.
And then plus or minus. And so what is this one?
Did you get?
What'd you get?
I wasn't watching.
Yeah, 570.
Until I got up there.
So you've done good.
It definitely goes.
I said, no, it can't be 8.
All the resistors are in? No, something else still playing.
It's good as
That's
it's
what
green,
I'm
but
doing,
it's-
hold on to the resistor.
I roofed it, yeah.
Yeah,
Service, and now you're in parallel with it.
Yeah.
Especially because my hands are a little wet.
But there's a tolerance there.
Okay, so here's a question for people who finish their playing with their resistors. Why is this one so much bigger? Why is this bigger? Anybody?
Higher wattage.
Yes. This can dissipate more power. The bigger the resistor, the more power. I think this, it should say what this is.
Probably a 1 or 2
This is
watts.
10 watts.
10
That's
watts.
a 10,
That's a quarter watt. This is a half,
this is a 5.
a 5. So that's why the resistors are bigger. And this one here, we'll see, it should say a wattage on
Probably
it.
5. That's
5 watts. Yeah. And So if you're going to dissipate a lot of power, that's the kind of resistor you need. Now we have some other devices. We have some other devices here. This is not a resistor. It's got one band on it. Does anyone know what this is? A diode, yes. Now, a resistor is a passive device. It's passive. It just, current just goes through it. It doesn't do anything, right? So it's called passive device. You'll get a chapter on active devices. A diode is an active device. A diode acts like a valve. It only sends electricity in one way, shoots it out the other. Well, some won't let it through. But the diode is the beginning of the transistor. Two diodes together actually are starting to make a transistor. Okay, so let's moving right along here. So that's something, you're going to get this on Thursday. You'll get this on Thursday, so not to worry. You'll have a repeat of this. It is sometimes a little... Yeah, the torus gives you a range of possible values for a resistor. So here we go, as an example on the test. Band B and D on a brown-black black resistor is silver, or 10%. What is the resistance in between levels? So it's 100 ohms, and it goes from 90 to 110. That's the typical kind of question they will ask you. There's a symbol for resistance. Okay, and now we're talking about batteries and cells. Okay, we have, these are batteries. They're not cells. A cell is one unit. There are many units that make up these batteries. If you have a 9-volt battery, I recommend you go to Sonic Northern and get a clip for it, like that. Never put a 9-volt battery in a drawer and close the drawer. There's a YouTube video on this. A fellow took the 9-volt battery, took a whole bunch of them out of his smoke detector, and he put them in a box without this clip. And they all touched each other, right? And there was power in there. They caught on fire and burnt his house down. Now with a regular battery, an AA, it's on one side and the other, so it's almost impossible, even if you put it somewhere, for two sides to be connected. But it's very possible for two sides of this to short out and cause major problems. So that's not on the test, but just to save yourself a lot of aggravation, buy yourself a little clip and put it on. Now the new batteries now, when you buy them, they're coming with a little bar of plastic on them. And you can just reuse that bar of plastic to put on to save yourself a lot of trouble. Anybody know what this is?
It's like
No? You know. What is it?
Bridge rectifier.
It's a bridge rectifier. There's a number of diodes in there. This, four of them. You use this in a power supply. And there's a chapter on power supplies that we're going to get to.
One or
Okay.
two methods to make DC.
Yeah. Okay. So now we're going to talk about batteries for a little while. There's a schematic diagram for a battery, and each of the long and the short is one cell. Put a number of them together, and you make a battery. Whoops. And you need to know this: series and parallel. If you put a number of batteries in series, the voltage is the sum of the cells, okay? I don't have anything which I could demonstrate it with, but if you take one battery and you put another battery and another battery and another battery in series, connect them in series, then you're getting the voltage of all of each individual cell, but you're only getting the amperage of one cell. Now, if you connect them in parallel, the positive to positive to positive, negative, 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 you're only getting the same voltage, but you're getting the amperage of all the cells. So that's something you need to know. Amateurs are doing that a lot. They're making power supplies and batteries for backup power, and how you wire them up is important. Okay, it's actually quite simple. Whoops. Now let's just go through batteries, because batteries are a real problem. We tend to use them in these, these radios of ours. This is a lithium-ion battery. As far as I'm concerned, this is the best we have right now. Flashlight batteries, don't suggest you use them because the outside case is one of the electrodes, as it's called, of the battery. And there's an electrolyte in there, which is usually a type of acid. And as the battery wears down, it actually consumes that outside casing, and so it can leak. Now, some of them will say they're not going to leak, but they can. I've seen them on clocks, and they all tend. The cheap batteries all will tend to leak it in and ruin your equipment. So amateurs tend to stay away from those type of batteries. Lead-acid battery, it's a very good battery, can be recharged. It's heavy, it costs a lot, it gives off hydrogen gas. And hydrogen gas is explosive. Okay, so that's a problem with them. Nickel-cadmium, very good battery. We used it in ham radio for years. The only problem is it builds up, it gets a memory problem. Unless it's almost totally dead by the time you charge it, if you charge it halfway through, then the next time it won't take the charge, They had reconditioners for these batteries, but you could still, some radios still have NiCads with them, but if you're going to buy a radio, get a lithium-ion. Nickel metal hydride, great battery, you can recharge it, has no memory problem, but you sit it on the shelf and it loses, I don't know what, 0.1% a day, 0.2%. The longer it stays on the shelf, it's completely, it'll be completely discharged. Lithium battery is great, but it can heat up. This battery in here, when I'm on 5 watts, it gets awful hot. People have tried it out. I know, John, if you've tried your full 5 watts on this transmitter, that battery is hot in your hand. So we have to not talk too long on the radio. She'll burn ourselves. Okay, so moving right along here. All batteries reduce their power in cold conditions. There's no battery that overcomes the reduction of power. And I guess what's happening there is the electrolyte in them is, the chemical in them is getting cold and not being able to react. Some batteries have good voltage but provide little power. So, like, why is it? You got a battery, you connect it, you test it on the voltmeter, it's good, but then it fails in the circuit. Why is that? Well, batteries have a thing called internal resistance. This item is always on the test. Internal resistance. And the internal resistance decreases the output of the battery. So here is a voltage divider. We're going to get to circuits. You'll get them next week. Here is your voltage out between these 2 points. This resistor is actually inside the battery. And you can't deal with it. It's in the battery, right? And as the battery gets older, this resistance goes up. And you've always got that resistance there. So the older the battery gets, the resistance goes up, and you might get good voltage, but you're not getting anything out of it. So this is a problem that occurs with most batteries. Internal resistance. And, it just means it's time to throw the darn thing out. Get another one. Okay. Circuits and schematics. A schematic is a drawing that shows the intended path of electrical flow. And you've got all these symbols. We've given you the resistor symbol. We've given you a whole bunch of symbols. And you're going to get more of this next lecture and all the other lectures you're going to get. But this is a very simple circuit to show you the battery, the light bulb, the switch, and conventional current. This is always so confusing. Conventional current and the flow of charge. They work in opposite directions. You really don't need to get into that for the test. If you really get into electronics, it might be a handy thing to know. So now there's an open circuit, a closed circuit, and you need to know the difference. The open circuit, of course, is a wire is broken somewhere. If we had this circuit here, okay, the circuit is now closed. If this the circuit is open. Or if the wire was broken here somewhere, had a bad connection, it would be an open circuit. But a shorted circuit would be, for instance, you know, the wire is going directly across the power. You know, so a short circuit consumes too much power. That's the question they're going to ask you on the question mark. What's the difference between a short circuit, open circuit, dead circuit? Short circuit is the one you don't want. It's consuming the power. It's going to blow the fuse or whatever. And that most of you already know that. Okay, so you'll be getting more of these on Thursday. So which circuit uses too much current? You see how simple these questions are? A dead circuit, well, I don't know what a dead circuit is. A short circuit, a closed circuit, or an open circuit? Well, it's the short circuit. Now, alternating current, we're just going to review that very briefly. What's in the chapter on root mean square is not on the exam, okay, so don't worry about that. But we do need to know some things about AC, because AC is very similar to RF, radio frequency, which we're going to be using. It's just at a different frequency. So alternating current has a constantly changing voltage, changing polarity and voltage in the shape of a sine wave. The frequency of the wave is measured in cycles per second, which we call hertz. You're going to really get into hertz because you need to know all of the radio amateur bands, and you're going to know them in hertz. 80 meter band starts at 3.5 megahertz. The 40 meter band, 7.0 megahertz. The 20 meter band, 14.0 megahertz. These things you'll know off by heart, because you need to know where to transmit and where not to transmit. It's illegal to transmit somewhere where we're not supposed to be. Okay, so we are not dealing with hertz, we're dealing with megahertz. And there again, the 80 meter band I've talked about. So, let's just use the roller here if we can get to it. That is the end, and a happy ham radio makes life happy. There you go. Now, are there any questions? Something we missed? Anything you need to ask?
Can you just go raise up back to that question I was asking about before? Just above the, they showed all the conductors, different gauge conductors. I didn't get that question clear in my head.
Okay, yeah, this is how they try to confuse you.
Just didn't get a chance to read it all. Bingo there. Just let me read that, so I didn't read it. So.
It's 0.5 volts at 10 feet.
Yeah.
So that's 0.05 volts per foot.
Per foot, yeah.
So the closest one is 0.03 volts per foot.
Yeah, I just didn't get a chance.
But see how they're trying to confuse you, because they're saying, what is the,
You look at the 22
what
amps.
minimum gauge? See, minimum gauge. There are other gauges that are better, but they didn't ask you that. What minimum gauge? And they throw things at you like that.
When I saw the 22 amps, I thought of gauge right away, right directly from that.
Yeah,
And that's, what, 10 gauge or above, 10 gauge, because if it's over 20 amps.
yeah,
So that's where I would have jumped at.
yeah.
So the answer was 8.
Okay. So, you keep in mind, they are going to try and trick you on the question bank. But that's why if you get this book, the book that we have available, you'll get most of the questions and most of the tricks that they're throwing at you. But as you can see, the question bank is a lot simpler than the textbook. The questions they're asking are pretty straightforward, pretty simple, not complicated at all. There's a lot of complicated stuff in the book that will throw you off. Don't get thrown off by it. Just stick with it, and you'll be fine. Yes?
Just a question about the test. Is there a time limit on the test?
No time limit.
So you can take it all day?
You can, well, we've never had one go over 2 hours. But most people have finished in an hour. But you can stay there as long as you need. Yeah, because 100 questions, 2 hours is really, you know, direct check, yes.
Is it gonna be paper or is it on the computer?
It's on paper, and you will, you just, there's instructions that come with it. You just mark each one with a circle. I think you mark it in, and then we have a key, and we lay the key over, and we just check. And it gives you a score, yes.
So the answer on that one was number 2, correct?
No,
one.
number one.
Because see, 0.03 volt is the closest to 0.05. 0.06 is over.
Oh, sorry, it's 0.5 volts though, over 10 feet, which is 0.05 volts
Yeah.
per foot.
Per foot.
So that's number 2, isn't it? Oh, that's per meter, I see, I'm sorry.
Yeah,
It's
per
per
meter.
per foot.
Yeah, at the end it's 0.3
Yeah,
per foot at the
okay.
end.
Yeah, this is how you
At
get
first I
confused
thought
on
it was
these
number
questions.
4, but 0.06 is a little too high.
Yeah, it's 2 different units.
You gotta watch the units. Now today,
That's from the.
or I have a burglar alarm in my house, and I'll go on my telephone systems, the bell came in, put the new panel in my house. And they had to terminate the, each unit in a resistor. And I said he had some resistors there, and the tolerance band was red. And I said to him, that's no good. I need a gold. But I was wrong, because a red tolerance is 2%, a gold tolerance is what, 5%, a silver is, so I was wrong. He went and found gold tolerances for me on those resistors, but I'd have been better off with the reds. And the poor fellow, what happened is, and this happens in electronics all the time, there's a fault somewhere in the circuit, and it was waking me up at 4 in the morning. I was going out, and the security company was called. My neighbor had to get the key, etc., etc. So it was a bit of a nightmare when this happened. And he had no way of knowing what was wrong with this thing. So with intermittent problems, they are a nightmare to fix in electronics because it's not acting up when you are testing it. When he tested it, it tested correct, right? The ohms were correct, continuity was there, everything was there. So he said, okay, fine. The only thing we're going to do, we're going to take the wire out, take the whole, all the cable out, and we're going to take the sensor out and replace it. So that's what he did. And he put the system on, what is it, bypass. So for the next 5 days, if it does alarm, it'll wake me up in the middle of the night, but they won't send the cops. Because the cops come with $85, right? So, any more questions, any concerns, any problems? Now's the time to bring them up.
I just have one question.
Yeah.
How many courses do you chance?
There's a lot more on, yeah, transmitters and receivers. Yeah, there's a lot on transmitters and receivers, and transistors, field effect transistors and that. This course only has a very brief introduction to transistors, but the other one has a lot more. But I found that, for me personally, I found that the advanced course was simpler than the basic. I thought the basic was harder to do than the advanced. Yeah. And you know, nowadays the advanced course goes into how you tune a radio transmitter with the tube finals. You know, it teaches you all of that. Well, yeah. There are some amplifiers that use tubes in them for ham radios, but they're switching to transistor finals. So the great beauty of radio now is, for instance, on my radio, if you bought the CD, you see a picture of my radio. The beauty of it is I go tune the antenna or match the antenna, hit a button, it goes click, 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 click. It's matched 1-to-1 SWR. I get a signal. You'll get all of this later, what the SWR is. You get a signal, and I'm not sure that I'm right on it, a Morse code. You click another button, it goes click, 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 and it tunes right in on the signal. Beautiful. I have a program that works between the radio and the computer. So all I have to do in code is copy the guy's call. RX5MA. I type it in, RX5MA. Bingity boom, the screen comes up, shows me the guy's name, Vladimir. Vladivostok. The distance to him is 4,000 miles. The bearing to him is 108 degrees. Shows me everything. I can even put, if I had a rotor on my antenna, that computer program would move my rotor to his direction, so I could pick him up.
How does he get his name and stuff? Is that in the digital code?
It's just on the CD.
Oh, okay.
It's just on the CD. It's got the whole, you know, we used to have, I think Ken Gamble still has some. You call it a call book. The call book was this thick.
Worldwide?
Worldwide call book. It was this thick in the old days. All of that now is on a DVD.
How many are we talking? How many people are we talking? A million?
Ah, jeez. That's a lot. People say, for instance, Morse code isn't used anymore. They say, oh, it's a thing of the past. You know what? If you go in a contest on the weekend, if you have a radio, listen on the 20-meter band, and it's plugged with Morse code all over the world.
It's actually fun to use.
It's fun to use, yeah. This should be fun. Amateur radio is supposed to be fun. We don't want you to sweat it too much. We want you to have fun. I think that's it, unless there's more questions. We've got to get out of here at 9. Okay.